So, hello everyone. Very good afternoon to you all. I hope I am audible. Yeah. So, let us start the begin this short course titled Introduction to Geosynthetic Applications. So, in this course, we'll be just introducing the basic types of geosynthetics. We're getting to know the types of geosynthetics, how they are manufactured, what are their various usages, right? What are the various functions of different types of geosynthetics, and for which type of function, which type of geosynthetic is particularly preferred. All right, then we will be studying a bit about the reinforced soil mechanism, and we will be doing solving some problems related to the reinforced earth walls. All those things we'll be doing. All right. So yeah, so let us just start slowly, right? Let us begin the session. So as this course is very concise and very compact course, it is a very compact course. So the problem is with the course is that I won't be able to go into the depth of everything and cover a lot of stuff. So what I will suggest you that I will recommend a book to you, and you should actually uh, go through the book by yourself also, so that you are able to understand the concepts in a much better way. All right. So yeah. So let us begin the course. And before we begin, I would like to thank the Institute of Smart Structures and Systems, uh, with the help of whose initiative I'm able to conduct this course. All right. So about myself, I am Ashish Chaudhary. I'm a PhD candidate at the Indian Institute of Technology, IIT Kanpur. My hometown is in Silchar, Assam, and I completed my undergrad in civil engineering from National Institute of Technology, Silchar in 2020, and then thereafter joined the PhD program here directly after completing my bachelor. And since 2022, I am a PMRF, that is the Prime Minister's Research Fellow. I'm Prime Minister's Research Fellow, and under this PMI program, we have to complete a certain number of teaching hours, and this course is also being conducted as a part of that. Something more about me, I love traveling, and also I play music, I play drums, and I enjoy doing them both. You can find more info about me on my website, and if you have any doubt during this whole course or in these lectures, please feel free to contact me over email at any time, ashish20 at iitk.ac.in, or what you can do, you can also message me on my WhatsApp number, which is 787-387-2969. Okay, so if you're from outside of India, don't forget to use the country code of India, that is +91, and then it is 787-387-2969. Okay, so I hope you have an enjoyable time. I hope you have an enjoyable time with you during these sessions. And I've also listed my LinkedIn. Okay, you can also message me on my LinkedIn if you have any doubts. All right. So yeah. So before I begin, I would like to mention that this course is inspired by the NPTEL course title Geosynthetics and Reinforcement Structures by Professor Rajagopal. And so materials from Professor Rajagopal's presentation will be utilized with explanation during the lectures in this course. And all the content of Professor Rajagopal's course are freely available in the NPTEL platform, and you can access that using this link. Okay. So as I mentioned, as this course is very short, you have to do substantial amount of self-reading. Right? You have due to substantial amount of self-reading, and for that I prefer this book. You should go to this book. It is Designing by Geosynthetics by uh, Robert M. Corner. So this book is one of the best books that I found that deals with the topic of geosynthetics. Okay, so the language is very simple and everything is properly explained. There are some example problems also. So please go through this book and you will see that if you read this book yourself, you will be able to understand the concepts in a much better way. Just a second. Check this. Yeah. Okay, so now just a second. Just a second. Let me check. So meeting is actually accessible to you. One second. Right. So I'm sorry for the interruption. So let us continue with the lecture. Right. So yeah. So what are geosynthetics? So what do you think geosynthetics are? So this is the normal, basic, generalized definition of geosynthetics. So geosynthetics are synthetic products, right? So this is geosynthetic term is made up of two words, geo and synthetics. So geo means geo earth, right? And synthetics is like something which is man-made, right? So geosynthetic are synthetic products typically made from polymers that are used in geotechnical, civil, and environmental engineering applications to improve soil behavior, provide reinforcement, filtration, drainage, containment, separation. These are some of the functions of the geosynthetics. These materials are durable, flexible, and engineered to meet specific mechanical and hydraulic properties. So we will see all of this as we progress through this lecture. We will see what are the mechanical properties, what are the hydraulic properties, what are the different types of functions that a applications of the functions that a geosynthetic can perform, right? Now, why are geosynthetics used and are helpful? Geosynthetics are used because they offer cost effectiveness, reduce construction cost by minimizing the need for natural materials like gravel or sand. So, if we use geosynthetics, lesser amount of natural materials will be required. We'll see that how, okay, later as we go through this course, we will see all of these things. Then we have improved performance, enhance stability, longevity, and function of any engineering structure. Third is the ease of installation. It is lightweight and can be installed with minimum equipment, and also it's very easy to transfer, easy to carry from one place to another. All right. Environmental sustainability used in landfill liners, erosion control, and reducing material transport. So we see all of these functions, all of this where how a geosynthetic is used, all of this stuff we are going to see. Now, if I show you these pictures, are you able to identify what are these? Which one is what geosynthetic? If you have some idea, okay, if we have a little bit of idea about what are these, can you identify? Or at least try, just make some guesses and we'll see if we are correct or wrong. Doesn't matter, right? So just try to make a guess. Some of you might be knowing this, okay? Some of you might be having a little bit of previous knowledge, or some of you might not have even a little bit of knowledge. For them, it will be little difficult to guess. But whatever the reason may be, just try to make some wild guesses. What are these? Okay, just try to guess and think in your mind what these stuff are. Obviously, these are geosynthetics, but which one is what? Which you? If you have some idea, if you have some idea, just try to make some guesses. Let's try to make some guesses. The first one, the first that is stuff that we see that is looks like some sheet, right? A white colored sheet over which we are pouring some aggregate, maybe, and here also we have some saturate kind of stuff. Here's some saturate, we are pouring some aggregate, and then there is some white colored sheet like stuff. Okay. A second thing that we see, we have say net-like stuff, some nets that are placed in layer. So here we have nets, okay, net-like structure is placed and that is attached to these blocks. Okay. Then we in the third picture we see a pond-like area. Pond is like okay, like a tank or a pond, which is maybe uh, lined with this plastic-like stuff, right? Plastic sheet-like stuff. Okay. And then here we have some, sorry, here we have some hexagonal sheet-like stuff that is visible here, right? So we have hexagonal hexagonal cells, honeycomb-like structure, right? Honeycomb-like structure, and within those cells, we are filling geomaterials. Okay. Here, if we see here is a corrugated sheet-like thing with a corrugated sheet-like structures which are covered with one more type of uh, clothing like cloth-like thing, right? Then if you see here, you can see one net-like structure again, and then at the top and the bottom you see some white sheet-like stuff similar to this white sheet maybe, right? And then here, if you see here, we are seeing some soil material kind of thing here in between, sandwiched between two layers of some stuff, some sheet. Okay, so these are the first initial observations that we are able to, right? These are the initial observations that we are able to make, isn't it? So now, so this first thing that we see here, the first thing that we see here, this white stuff. Okay, yeah. So the first thing that we see here is this white sheet, over which over the white sheet we have placed some pebbles or stuff. Okay, so this thing is the geotech. Geotextiles. Okay, these are textile like stuff things. Okay, and these are called geotextiles. Okay, this is called a geotextile. So we are whatever we are wearing, this is also a textile, right? So similar to that, that is also something a textile like stuff, a textile, but it is used in geosynthetic geotechnical applications. So we are calling it a geotextile. Then this grid-like or net-like thing that we see here, this is called a geogrid. Okay, this is called a geogrid. Okay, we are seeing some grids, net-like structure. These are called geogrids. So these are mostly used in our reinforced earth wall designs. Okay, reinforced soil wall designs. Okay, this is called a geogrid. The third image that we see here, I said that is a tank-like thing. Okay, a tank-like area where the tank-like thing is actually lined by a sheet like a plastic sheet like material. So these are nothing but liners. These are called liners. These are used in this, say, some containment ponds or something. Okay, these are liners. So when we line the soil with this, so it will hold whatever material you put over this area, right? It won't let that material to pass into the soil. So these are known as liners. And actually these liners and these are actually also called geomembranes. Okay, I'll write it here. Geomembranes. Okay, geomembrane. Let us come to here. So here we have some cell-like arrangement, hexagonal cell-like arrangement. These are also filled. So these are called geocell. Then here we have some corrugated sheet inside and outside also you have a geotextile that is covered. So we have some corrugated sheet inside and outside we are covering that with a geotextile. So these are long slender structures, flat slender. We'll see that. So these are called PVDs, prefabricated vertical drains. Okay, prefabricated vertical drains. Prefabricated vertical drains, PVDs. Okay, let us come to this one. Here also we are seeing this net-like thing, but this net-like thing is not similar to this. Here, if you see the nets very clearly, they are not in one same plane. Okay, these are in different planes. So what will happen? It allows water to easily flow through it. Okay, so and these are sandwiched between two layers of geotextile. So we will see what are the why it is done like this. We will see that later. We will discuss that later. So these are called geocomposites because this is made up of two types of more than two types of geosynthetic. This is a geotextile, right, and this is a geonet. Okay, okay. Now let us see this. Now this is also a type of liner that is used. This thing this is also a type of liner. These are called geosynthetic clay liners, GCLs. So here, this white material that you see here, this is nothing but a type of clay material. It's called bentonite. You might have heard about it when you have studied about basic soil mechanics. So this is called bentonite. Okay, this is called bentonite. Okay, and this also helps as a acts as a liner. Okay, liner. Okay, so these are some of the main basic types of geosynthetics. Okay, basic types of geosynthetics, and we will be discussing more about them. Will when we'll as we progress through the course. Okay. Now, this was one of the site visit that we did during my BTech days, my undergraduate study days. So here we had an area where uh, PVDs were used. So the main you must have studied about sand drains, right? When you studied about consolidation, you should have studied about sand drains. So what these PVDs do? So these white stuff that you see here, these are nothing but the PVDs. Okay, so these are the rigs that are used to install the PVDs. So these are the PVDs that are concerned. So what these PVDs do? These PVDs actually accelerate the consolidation process. So say previously, for general process of consolidation, it would have taken 10 years to achieve 90% consolidation, but now the same amount of consolidation can be achieved within 6 months if you also introduce these PVDs. Okay, these are some alternative to sand drains. So sand drains are difficult to construct and also they are prone to damage a lot. So sand drains, instead of sand drains, we can use PVD. So PVDs, so sand drains, you should have studied in your geotechnical courses, basic soil mechanics courses when you have studied radial consolidation and all this stuff. So these PVDs are an advanced geosynthetic that is used for this radial consolidation, to an accelerated consolidation. Okay. Now, as I said, there are various function of it. So I will give you 1 minute. Just go through the different functions of but different. I've listed out the functions. Just go through these different functions and descriptions by yourselves for a minute. Okay, then I will discuss them. Okay, okay. So just I will give you 1 minute to just go through this by yourselves first. So you have read it, right? Read the function. So what is the first function? What is the first function? The first function is a separation. So what is the separation? Separation means it prevents mixing of different soil layers. Okay. So now say you have subgrade. Okay, you have a soil subgrade. Okay. Over that you are placing some chips or boulders layer. Okay, some aggregate layer. Okay, then again you are say placing some soil layer like this. So for a unpaved road, for examples. Now, what this separation does is that so if we do not generally what will happen, say if you apply some load over these aggregates will come inside, will try to go inside this soft soil subgrade, or what will have the intermixing of the layers will happen. So due to this, what we will have some undulated surface over the top, and all those stuff will happen, right? But what we do, what if you put some between these layers, if you put some geotextiles, okay, if you put some geotextiles there, then what will the geotextile do? This geotextile will separate the layers. Okay, so what will happen? It will do that. It will prevent the intermixing of the these layers, right? And apart from that, it will also give some strength, which is known as membrane effect. For that, you can go through the textbook. We will also discuss it later a bit, and the later lectures we will discuss it. But now, if you want to know, you can also study this. Okay, there will be some kind of a membrane effect. So there is a strengthening also due to this. All right. Next function is the reinforcement. So what is reinforcement? Improve strength and stability of soils or embankments. Now, what is reinforcement? Reinforcement, the most common application of this reinforcement function is the reinforced earth walls, right? Where what we do, say you want to construct a approach road, right? Approach road. So you have seen that flyovers are constructed, right? Flyovers are constructed over the in the road, right? Flyovers are constructed. Okay, these are the piers, these are the piers. Okay, flyovers are constructed. Now, to construct the approach road, what we do, approach to the flyover, generally what it is done that we construct a reinforced, you must have seen these soil blocks, like these blocks, like this block-like structures you might have seen in the road, right? So what we do for this purpose, to construct this approach area, what we do with instead of making piers, what we do, we construct a reinforced earth wall. Okay, we reinforce the soil so that we can construct a approach road over it. Okay, or else say we want to construct a steep embankment. So generally with the available soil, you are able to construct an embankment like this. Okay, now what we can do, if we reinforce this, if we want to construct a reinforced embankment, you can have more steeper configuration, right? We can put reinforcement like this. Okay, then we can construct a steeper. So with this we are saving a lot of geometrical soil materials also, right? So and the more important function of geosynthetic is the reinforcement function. Okay, these are most application is simple application of it's a reinforced earth wall. So you'll be solving problems with seeing the simple design of these earth walls later. Okay. Then we have the filtration. So the filtration means allows water to pass while retaining soil particles. Now say you have a retaining wall. Okay, you have a retaining wall and you have few weep drains like this. Okay, you have weep drains where water. So you have the soil here. So water can pass on because we don't want water when the soil is wet. We want the water to drain out from the soil because the water pressure is very high, right? So if water is there, it will create a lot of extra pressure on the lateral pressure on the retaining wall. So retaining wall might fail. So we want the water to drain out. So for that, what we do, we place a layer of filter material and a drainage material here. Okay, so these go hand in hand. This filtration and drainage go hand in hand. So what will this filter material do? We will place a filter material here between the soil and the wall. So the filter material will allow the water to pass, but it will prevent the soil particles to pass. And then what we do, we put a drainage layer here. So drainage is mostly done with the geonets that I showed here before. Okay, is geonet. So we'll place one geonet here, and filter for filter mostly use a geotextile. Okay, so we will put a drainage layer here. So what will happen? The water will come, soil particles will be arrested here. The water will enter, it will come down and will be drained out through the weep holes. Okay, so these are the functions. What is filtration? Allows water to pass while retaining soil particles, and what is drainage? Facilitates flow of water within the same plane of the material. Now next we have the containment or barrier, that is acts as an impermeable layer to restrict fluid or gas movement. So this we already uh, uh, saw, right? So this containment effect that is there, this containment or barrier, we already discussed it when we discussed the liner. So say you want to contain some material within an area, within a ponds. So what do you do? You line that pond with some geomembrane or geosynthetic clay liners. Okay, that is called the containment or barrier function. Then we have protection. Protection means protect other materials or structures from damage. Say we put some geomembrane, so or to protect that geomembrane over the geomembrane also we put some layer of say geotextile. That is the protection. And then we have the erosion control. Erosion control prevents soil loss due to surface runoff or wave action. So we want to prevent erosion from area. What we can do? We can place some geotubes or some what to say, some other things. Okay, some geotextile over there so that it prevents the soil to pass out. Water can easily pass out. We prevent the soil. Okay, just go through this again. I'll just give you a minute again. All right. So now let's go to the next one. Yeah. Now, as I said, we have seen these functions, right? So now which geosynthetic is used for which purpose? Let us see. Generally, which geosynthetic is used for which purpose? Let us see. First is the separation between separate soil and aggregate in unpaved road. This is one example that I discussed with you. One most probable example where in unpaved road between the separate soil and the aggregate, we use this geotextile only. Okay, generally, we use a geotextile to perform as a separator. Okay, because we have this unpaved road and then we have aggregates, right? So that the aggregates do not get into the subgrade and disturb the uniformity of the unpaved road, what we do, we put a geotextile layer in between, which prevents the aggregates to enter into the soft subgrade. Okay, so this function is called the separation function. So generally, what we use a geotextile. Okay. Next we have the reinforcement. Okay, reinforcement. So reinforced soil retaining walls and embankments. So that is the most uh, easiest example that I discussed, right? Reinforced soil retaining walls or embankments. So what we use for reinforcement purposes, we generally use a geogrid or a geotextile. So most commonly we use geogrids. Okay, and then the third function is filtration. So filtration, what we do as I discussed between retaining walls to prevent soil clogging of drains. Okay. So filtration, this also I discussed. So for that, what we use non-woven geotextiles. So geotextiles are textiles, right? So these whatever cloth that you are wearing, that is also a textile. So these are woven in a machine, right? These are threads are woven, and then these textiles are formed. So these are woven. So similarly, geotextile that are also weaved. Okay, weaved into a machine. Okay, its sides are weaved together. These are called woven geotextile. Apart from that, we also have one more type of geotextile, that is the non-woven geotextile. The non-woven geotextile, these are various like needle punched or heat bonded. So for that, what I suggest you please. So this topic, this part, initial part, introduction part, this doesn't have any math or stuff, right? So this it becomes tends to become a little bit boring. So I did not want to give show everything here. So what I suggest you that you please go through the book Designing with Geosynthesis by Robert M. Corner that I suggested to you, that I already suggested in the initial slide. Please download that book or buy that, purchase that book and go through this. Okay, there you will see all the different types of geogrid and geotext. So everything clear detailed description is given. Also the manufacturing process are also discussed in detail. Of course, we are going to discuss them a bit, but we are not going to discuss them in detail. So what I suggest you please go through them in detail in the book. Okay. The filtration also used geotextile. Next, we have the drainage. For drainage, we generally use a geonet or a drainage composite. Drainage composite is nothing but this one. This is a drainage composite, geocomposite, geotextile layers, and between you have a geonet, or we can use only a geonet. Okay. Then containment or barrier liners for landfill or canals to prevent leakage. So for that, always use a geomet. Then we have protection, protecting geometry liners from puncture in landfill base that I said already. So we use what that we use. Needle punch, and then we have erosion control, river banks, slopes, and coastal protection. Again, for that we use yourself or erosion control blanket. Now, these geosynthetic, so these are, as we said, these are synthetic materials. So these are made of synthetic polymers. So what are the different types of polymers that form different types of geosynthetics that we have discussed here? And some of the properties also have discussed here. So for this also, again, I suggest you to uh, please go through the book properly. Okay, please go through the book by Robert M. Warner. So please go through that book properly. If you go through that book, everything you will get to learn everything in more depth. Okay, you will gain more depth over the topics, and you're also able to learn more stuff. Because as I said, it's not possible that I discuss everything in this 14 hours or this in this 1 week. Okay, because we have some to cover. We cannot spend much time over this topic. So these are mainly theoretical topics. So I suggest that you please go through the book. Okay, please go to the book. Please study the books. Study that book, and you read that book. It's written in very simple language. You'll be able to understand. But it's very necessary that you should know. Okay, you should not ignore these topics. Okay, you should not. You should know that which geosynthetic is made up of which material and how these are manufactured. So how each of these geosynthetics are manufactured. So as a geotechnical engineer, it's very important for us because when a supplier supplies some material to us, we should know what are the properties that are what material it is made up of, whether proper testing has been done or not for that. Okay, what are the constituent properties of each of the polymers of which makes that geotechnical. It is very important to know for quality control purposes. It is very important for us to know all those stuff. What I suggest is that please go through these things. Okay, go through everything in the corners book. Everything is given in detail. So please read that properly and try to remember also. So what are the polymers that are used in geosynthetics? So we have polypropylene. Okay, so polypropylene, the properties that it is chemically inert, lightweight, and resistance to acids or alkalis. And these are mostly used in geotextiles, geogrids, and geonet. Okay, then we have polyethylene. So polyethylene is it has high flexibility, it is UV resistance because polyethylene, you must have heard about high density polyethylene, right? HDPE. So HDPEs are also used to make pipes nowadays. So these are very is a very high flexibility and these have good amount of strength. Okay, so polyethylene is generally used to make geomembranes, geonets, and geocells. Then you have polyester. These have high tensile strength and low creep. These are generally used to make geotextiles and geogrids. And then we have PVC, that is polyvinyl chloride. So PVC, these are flexible, low cost, less chemical resistance than polyethylene. but these are generally used to make geomembranes. Then we have polyamide, this is nylon. These have high strength and low resist, but they have low resistance to acids. They're occasionally used to manufacture geotextiles. Then ethylene or polypropylene monomer. These are highly elastic and UV and water resistant, and these are used in flexible geometries. Okay, so these are some of the polymers. So as I said, please go through the textbook that I suggested, Designing with Geosynthetics. So if you go to this textbook, you'll be able to learn more about these things in a detailed way, and you should actually remember, also try to remember which geosynthetic is manufactured with what kind of polymer. Okay, now let's discuss the manufacturing method. So this manufacturing method is also a very lengthy topic, right? It is not that very short topic, it's a lengthy topic, and every manufacturing method, most of the important manufacturing methods are uh, given in detail in the book that I mentioned, Designing with Geosynthetics by Robert M. Corder. Okay, that is given in detail in that book. So what I suggest is that again and again I'm saying is that please go through that portion also. You go through the initial introduction, and you go through the uh, these materials, these polymer topic, and then you go through this manufacturing topic. So for all the different types of different manufacturing methods are used. So those are also given in detail in the book. So please go through detail. So now just let us just discuss them in very short. So the first geosynthetic that we're discussing is the geotextiles, right? So for geotextile, as I said, we have two types. One is woven, and that is non-woven geotextile. So woven geotextile is nothing but like our clothes, our textiles. That is also very woven. And non-woven is also one more type of geotextile. So if you want to see some pictures, you can do. I can search here, right? No, here. Okay, so yeah, yeah, so you're correct. So these non-woven geotextiles look something like this. Okay, we cannot see some definite weaving pattern or some definite thread. We cannot see that. Okay, if you see very closely, you see that you cannot see some weaving pattern. Okay, nothing. So these are the non-woven geotextile. If I want to see woven geotextile, it is at this kind. These are proper this you can see, right? These are woven. You can easily differentiate. So these are this textile kind. So these are easily distinguishable, right? So woven geotextile is very interlacing yarn. So yarns means this threads that you're using. So we inter interlace these yarns like this. You may form an net like interlacing, and then from that you get the and non-woven geotextile. So we have some threads and we will punch them together, or you heat bond synthetic fibers to form the heat bonded non-woven geotextile. So these are two types of geotextile. So for where we use what, this also mentioned here. Woven geotextile is used for strength purposes. That is wherever you want to use for say reinforcement, separation, all those things. Generally, we try to use woven geotextile. And non-woven geotextile we generally use for filtration or drainage purposes. Okay, these are used for non-woven. Non-woven geotextile are used for those purposes. Next, we have geomembranes. So what are geomembranes? So geomembranes that we already discussed. So how are geomembranes made? Geomembranes are nothing but plastic sheet kinds of thing, right? So those are made from extrusion of polymer sheet, and we have a process known as calendering. Then we coat that sheet. There is known as calendar. So these methods are already discussed uh, in detail in the book. So please go to it. So HDP and PVC are commonly used, and the thickness also varies. So let us try if you want to search. So like this calendaring, yeah, this is the process of calendaring. It is passed through so different types of rollers like this. Okay, different types of rollers, and you get a long sheet of geo membrane. Okay, so these are passed like this. You feed the material like this, and then it passes through the rollers. Supply the polymer, when you apply it, heats up, then it's formed into sheets. Okay, like this, like this, like this. Okay, supply the polymer, everything. A sheet comes in, and then later it can be also coated also. Okay, so everything is given in detail in the book. Please go through it. Okay, then you have geogrids. So geogrids are also two types. You have extruded and woven or knitted. So woven or knitted, you already can understand now. So is woven, like similar to geotextiles, these grids are woven. And one more type is the extruded. Okay, extruded means there can be punch or so you have a sheet, you have a sheet of plastic shade, then you punch it and then you put it. So you get this grid-like structure. These also images you can see here. This process images are not shown actually properly, but hope you can understand, right? The geometries are generally used for soil reinforcement. Next, we have geonets. So geonets, extrusion, geonets are also formed from extrusion into a net-like structure within three layers. So geogrid is actually in one layer, but geonets are actually more than one layer. Okay, more than one layer. You have the web that is formed, the net that is formed. So that is it is useful in plane drainage. So it helps water to pass through the layer of the geonet. So you know water. Then we have geocell. So geocells are HDP strip, also astronomically welded to form 3D honeycomb-like structures. Where are they used? They're used for load support and slope protection. Okay, then we have geocomposites. Geocomposite is a combination of geotextile, geomembrane, or geonet. Geocomposite for specific purposes. Okay. So before we go bold, I will show you some, let us search and discuss some pictures. Okay. Geotextile. So you can see these are some of the applications. So you can see this is a geotextile that is used for this reinforced. This is a vertical reinforced earth wall is constructed with the help of this geotextile reinforcement. Similarly, that geogrid is being used for the similar purpose, right? There are many uses actually. We'll discuss one by one later. There are not many good images. Soil erosion control. Yeah, see, here are using geocells for soil erosion control. So you place the geocell and you fill it with soil, and later on you will see vegetation also grows up in that. Okay, so it looks very good also. Here also you can see the slope is protected, so geocells are placed and then filled with soil. Some of the pictures. Yeah. Okay. Let's see what we have next. Just a second. Huh? Yeah. So why do we actually need to test geosynthetics, right? What is the purpose of our testing geosynthetics, right? So yeah. So we saw the different manufacturing methods. Now say you have some sample that you have ordered from some supplier and you have got some samples, right? Now if you want to check whether these samples meet to the criteria that you had asked the supplier for. You specify some requirements, right? And the supplier is going to fulfill those requirements and is going to say that yes, say you are going to say you need a grid having a tensile strength of this and this. Then you tell the supplier to supply you that geogrid where that satisfies that criteria. Now you get the stuff from the supplier. Before you implement it in your site, what you have to do, you have to test that yourself also. You have to take a sample, and then we need to test it. Test and check whether the quality of the material that the supplier has supplied to you is perfect or not, is able to meet your requirements or not. Okay, so these are some of the reasons why do you need to test the geosynthetic. The first is the ensure product quality. So testing verifies that geosynthetics meet manufacturing standards and specification. For example, strength, thickness, and weight. These are some of the basic properties that initially you need to check. Then assess suitability for application to different applications. Example, drainage versus reinforcement uh, requires different properties like permeability versus tensile strength. So you need to assess the suitability of application of a particular geosynthetic. They have long-term performance. Geosynthetics are expected to last for decades. So you need to test for durability. So first to ensure that the basic product quality is fine, that is the strength, thickness, and weight. These are basic physical properties. Those you have to check that are fine. They need to assess the functional property. This is either if you are using for drainage, then you have to test the drainage properties such as the drainage properties, right? That is permeability. And say if you are using the geosynthetic for reinforcement purposes, you need to check the tensile strength. Okay. Then you have to check for the long-term performance. So geosynthetics, you are keep placing it on the site over, and it is acting, it is being acted by sun, rain, wind, everything, right? So you need to check whether they are durable enough or not. For that, there are also various tests. There's a creep test, chemical resistance, UV aging, and all those things. So you need to ensure that it will maintain a proper longevity. So that also you have to check. Then you need the in design parameters for your designing. When you design that, so engineers need reliable data tests. Example, tensile strength, puncture resistance, permeability for accurate design. Okay. Now, compliance with standards. So many infrastructure projects require materials to conform to ISO, STM, or EN testing standards. So for that also you have to test them. Okay. Then we have the safety and reliability. In critical applications like landfills, dams, retaining walls, failure of geosynthetic can lead to catastrophic consequences, right? So if you dam, you've constructed an earthen dam, which is actually reinforced with the geosynthetics. We don't want the geosynthetic to fail, because if that dam fails, there will be a lot of loss of lives, right? Because it stores a huge amount of water. Dam fails, water is going to inundate on the downstream side, a loss of lives will be lost. A lot of lives will be lost. So we do not want that. Okay. And then we have the construction quality assurance, QCA, CQA. So on-site also we need to test that whether there is proper installation, there is no damage, and consistent performance is being established with the design. Okay, that also. Okay, so these are the basic reasons why we need to test your synthetics. Now, now to do the testing of geosynthetics, there are different codes that are there. So you can see here some of the codes. So ASTM B4354 standard practice for sampling of geosynthetic for sensing testing. ISO 554 standard atmosphere for conditioning and testing specifications. Then we have ISO 9862 geotextile sampling and preparation of test specimen. Then IS 14706, we have geotextile sampling and preparation of test. All those different testing codes by different agencies are given. Now, what are the common properties that are tested? So first we have the physical property. Okay, we have the physical properties. We have thickness, such as mass thickness and mass per unit area. Then we have mechanical properties, tensile strength, tear resistance, puncture resistance. Then we have hydraulic properties, permeability, permittivity, transmissivity. Then we have durability, UV resistance, chemical resistance, creep, oxidation. Then we have interface, we have friction angle with soil, and peel strength. All these things we have. Okay. Now these are some of the basic properties of geotextiles. Okay, physical properties and mechanical properties, both of geotextiles. So we have physical properties, we have specific gravity, mass per unit area, thickness and stiffness. Mechanical property, compressibility, tensile strength, seam strength, fatigue strength, bar strength, tear test, impact test, puncture test, friction behavior, and pull-out test. That's huge area of properties. So all these details you can find in the book. Though we do not have time to discuss everything in detail, we will discuss some a little bit. We will discuss, but again I suggest that you please go through all of this stuff in detail, and for that please refer to this book that I have asked you to. Okay, the design which you every test is almost in detail, considerable detail. Everything is mentioned, and you can read and easily understand. So here some of the properties are mentioned, the type, the purpose of the test, and test code that is also mentioned. So please, this might not, all of these codes might not be correct also, but still you just verify it yourselves. Okay, verify this thing yourself by searching over the internet whether the codes that I've listed are correct or not. Okay. First, we have mass per unit area, GSM, that is gram per square meters or something like that. Mass per unit area. So we have type, it's a physical property, right? And why it is used for basic identification and used in design review. So the test method ASTM D5261 or ISO 9861. Then we have the thickness, that is also physical property. What does it indicate? It indicates structure and flow capacity. So we'll see that as the thickness reduces, the the capacity of that geosynthetic to pass uh, fluid through it. So say for drainage purpose, that also reduces. So that is directly related to the thickness. Yet one more important property, we have the apparent opening size, AOS. That is one of the most important properties. Okay, so what that is, we say, it describes pore size relevant for filtration. So we'll see that later also, what AOS is. Then we have permittivity, the hydraulic property, water flow rates across the thickness, that is this cross plane flow. So this is a geotextile like this flow. This cross plane flow is given permittivity. So we have two things. Okay, we have permittivity. Permittivity is actually in plane. We will see that in plane flow and what is in plane flow and cross plane flow. We'll see that later. Then you have tensile strength and elongation. It measures strength and flexibility. Then you have tear strength. It is the resistance to tear propagation. Then you have puncture resistance. Is nothing but tested for the CBR. Resistance to penetration. There is penetration from stone or impact, stone impact. It is measured by the puncture resistance test. Then we have grab tensile strength. So quick index tensile property. Then we have bar strength, resistance to hydraulic pressure. Then you have static puncture strength, that is resistance under static loading. Then we have the UV resistance, that is durability, is also durability resistance to degradation from sunlight. So as I said, this thickness indicates structure and flow capacity. So here, this example is actually given here. So compressibility. Okay, so here the compressibility of different types of geotextiles that are given. So if you see here, this non-woven needle punched, okay, non-woven needle punched heavy, that has the highest compressibility, right? So when the applied stress is less, the thickness is very high, but when the applied stress is high, the thickness is reducing a lot. So NW needle non-woven needle punched. Then you have non-woven needle punched light. Then you have non-woven heat bonded. You have woven monofilament, woven silk. So this monofilament and slit film, these I am not discussing now, but what this monofilament is and what this slit film is, that I suggest you go in the learning videos in the book that is given in detail. So see, so similar to this no non-woven geotextile where you have needle punched or heat bonded, these categories. Woven geotextile we have monofilament type or slit film type. Okay, there are two different types, so that you can also see in the book that is designing with geosynthetics. Okay, so these type of geosynthetics are obviously more compressible. Non-woven needle punch type geosynthetic geotextiles are more compressible. And if you have a look here, this woven geotextile or non-woven heat bonded geotextile, these are less compressible. Okay, these are less compressible. So with increase in the applied stress, the thickness is not changing that much. All right, so these are less compressible. Okay, so now as I said, there are certain tests. Okay, certain tests to determine the tear resistance and all those things. Tear resistance of a geotextile, whether it's going to tear easily. We do not want that. Right? We do not want the geotextile to get damaged easily. So there are certain tests. So this is one of the tests known as the trapezoidal tear test. Okay, so from there also we can get some tensile strength of the. You can measure the tensile strength of the geotextile. So what we do, we have a geotextile of it is given by ASTM D4533. So we have a geotextile specimen 200 by 76 mm, and then we make a cut in the geotextile like this. Okay, we make a cut 15 mm cut here. Okay, one and we make a 15 mm cut here. Okay, and we hold the geotextile by gripping along these dotted lines that is given here, right? We hold the geotextile like this by gripping along this dotted line. So everything without a test gap is given, rate of test is given, and shell gap is also given. Initial gap between the what? Between the grips. Okay, these grips that is holding the geotextile. Now, what is going to happen next is that we are going to pull it apart and we are going to allow the this to tear. 15 mm cut is there and this 25 mm is the difference between the grips. Okay, let us see this video. Okay, so basically it is getting teared up. Again, let us. So these are actually the grips that are pulling it apart. We have some small and we are just pulling it to tear it up. Okay, so this is how this trapezoidal test is done. Okay, trapezoidal tear test is done. Then we have the grab tensile strength test. Okay, this test is actually used to measure a type of tensile strength known as the grab tensile strength. This is measured by ASTM D463. So, okay, this measures the grab tensile. This is the grab tensile. So say you are placing a geotextile here, okay, and you have some boulders like this, okay, you have a boulder like this. So now you, if you apply load here, what will happen? These two boulders will be pulling the geotextile apart. Okay, in order to simulate this scenario, we do this grab tensile step. Okay, so this is the done to test the construction survivability test, especially for separator applications in pavement. So as I said, in pavements you have a subgrade, then we put some boulders here. Okay, in between we put the here we put the at the interface we put the geotextile. And below we have the subgrade, and here we put the boulders. With in those boulders, when this load comes, there are chances that we will tear the geotextile apart. So to test for that, what we do, we do this kind of test. Okay, test result in force is newtons in the rupture strain. Loading rate at 300 mm per minute. So you can see this test diagram is also shown here. Test diagram is shown here. So you have a geotextile. These are the grips are 25 mm wide. The initial clearance is 75 mm. Then again 25 mm. So 100 by 200 mm test sample we have value test. Let us see this test video. Here it is pulling on the right side. I'm going to make it slower. So this is by sample on the right side. This white color is by sample, and we are pulling it. Huh? Initially, the graph is rising, 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 and then it will have a sharp drop. That means the sample has failed. Okay, so the maximum that has gone, that is my graph tensile strength. Okay, let's watch it again once more. You can see the load is also increasing, 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 and then it drops. Right? It failed. There is a sample fail. So this is how this test is done. Now, geotextile can also be, we can make some tubular structures also. Okay, tube-like structures also with geotextile. These are known as geotubes. So, geotextile tubular structures undergo large strains due to deformations and ground movement. So, these geotubes are actually used in this offshore, not offshore, actually, these are used in this shorelines too, for the shore protection. Okay, to protect the seashore from the impact of the waves and all those stuff. We generally use this in the for the shoreline protection. So the large tubes, like say that this man is standing over one of the tubes, right? You can see. So these are large tube-like structures that are placed on the shoreline to save up our save the coastline. Okay. So geotextile tubular structures undergo large strains due to deformations and ground movements. Pores developed in fabric is very low as they are not completely filled. So generally, we do not fill up these tubes completely. So force generated is not that much, but this undergo large amount of strain. Okay, this undergo large amount of strain because there is impact of waves. There is a lot of movement in that. Waves are coming. There is a lot of movement, but the force is not that much. And the forces depend on the field ratio. Application of geobags and tubes for shoreline. This is the application of the geobags and geotubes for shoreline protection. So here we can see some tensile strength versus strain rate plots for some groups of geotextile. So this initial, there are five A, B, C, D, E, five samples. A, B, C sample are woven type, right? Woven, and D and E are non-woven type. Now, tell me which group. So say this is group one, ABC is group one, and DE is group two. So which group of geotextile would you prefer for the application is geobags or geotubes, and why? Whether it will be ABC or whether it will be DE. Which one? Just think for a minute. Of the tensile stress versus tensile strain now, which one do you think that you will prefer for this geobags or geotube application, and why? What is the reason? Just think for a minute. Please think. Please think about this, okay? And I will ask you the answer tomorrow in tomorrow's class. Now, one more property is the punching strength test. It is given by the ASTM D4833. So 8 mm diameter probe is punched into a stretched geotextile. Container diameter is 45 mm and peak load developed is reported in Newton. So this is for the punching resistance. So you stretch the geotextile in the circular uh, container and then you punch it with a 8 mm diameter probe. Okay. So that gives you the punching strength and that we report that in the mm. Okay. Uh, So let us watch this video. So there is a stretch geomembrane within this container, and then we punch it with the uh, this probe. Okay, and you can see that there is a punched part in that geotextile, and we measure the peak load that was recorded during this experiment. Okay. Now we saw the mechanical and the physical properties. Now let us discuss about some of the hydraulic properties. Now, what is permittivity? Permittivity is the measured cross-plane water flow rate per unit thickness. That is the permittivity. And the permeability is nothing but the permeability per thickness. Okay, we'll see that just in the next slide. You will see what is permittivity and permittivity. The permittivity. Okay, this is measured as per the STM D4493. It measures the cross-plane water flow across the geotextile. Then water flow rate indicates how much water passes through the geotextile per unit area. Then we have transmissivity, measures the in-plane flow capacity between two surfaces of the geotextile. So permittivity measures the cross-plane flow, transmittivity measures the in-plane flow. Now, say you have a geotextile, you have a geotextile. So the in-plane flow is measured by the transmissivity property. And the cross plane flow is measured by the permittivity. So permittivity is cross plane, transmissivity is the in plane. We will see that. Next, we have the aperture opening size indicates equivalent pore size important for soil retention and filtration. Then we have gradient ratio evaluates clogging potential of a geotextile and used with soil under long-term flow. So the gradient ratio is a gradient ratio test is done as per SWD 5101. So gradient ratio test actually helps us establish whether there is a compatibility between a soil and a particular geotextile and whether that geotextile can be used for long term for that particular soil to retain it for use as a filter for that particular soil. Okay. So it actually evaluates the clogging potential. So what happens generally as water will pass and it will the geotextile will keep on acting as a filter, the pores of the geotextile might get clogged. It might get clogged with the soil particles, and if it get clogged, then water won't be able to pass through it. So we need to do this gradient ratio test to establish this compatibility. So we want this filter to perform for a long duration, right? So we don't want the material to get clogged into the pores. So we do this gradient ratio. Then you have the soil retention or filtration efficiency determines the ability to retain soil while allowing water flow. This is done as per ISO 11058 or plus for the filtration. Then we have pore size distribution describes the range and distribution of pore sizes. Now, as we said, there is a property known as the apparent opening size. So this property is very important. The ASTM method, also called the dry method, uses the glass beads of wind. So you use glass beads of uniform size. You use beads, small beads, glass beads of uniform size to determine the apparent opening size. A test method involves in sieving uniform size glass beads through the geotextile. The main advantage is that it is relatively faster compared to other methods. So sieve and we find out the apparent size. The process given here, take 50-gram mass of small size glass beads, 75 micron size, and sieve them for 10 minutes and determine the percentage retained on the geotextile. Repeat with next higher size glass bead until percentage of glass beads passing through is X% or less. A graph is drawn between the glass beads on X size, glass bead size on X-axis and thus percentage passing on Y-axis. So similar to the grain size distribution curve that you make for the soil after doing the sieve analysis, the same methodology is adopted here. Okay, you have to see when you will plot the size against the percentage final, right? So if X% of a certain particle size is retained on a geotextile, the OX of the geotextile is the size of the particle in mm. Usually 90% and 95% are used in the literature. So ASTM designated aperture opening size is 0.95. So if anyone says you what is the apparent opening size, generally it means 0.95. So 0.95 corresponding to 5% particles. 0.95 means 0.95 size means that 5% particles are passing through the geotextile. Okay. Okay. Understood? 0.95 size means 5% particles passing through the geotextile. Percentage final is 5%. Okay. So let us see this. Okay. The test results for a woven geotextile is shown below in figure 1. Can this geotextile be used as a filter if the grain size distribution curve for the soil is shown in the figure 2? So there is one figure. This is figure 1. And this is figure 2. Okay. So in the figure 1, we have the test result for this apparent opening size that is done. So we have two sizes that we have got. O90 size is 150 microns and O95 size is 230 microns. Okay, so right. Okay. Just a minute, let me just check one thing, huh? So O95 size is my 150 microns. Okay, and O90 size is 150 microns and O95 size is 230 microns. O95 size means what? Means 5% final, like this size. Okay. Uh, um, now for this, can this to answer this question, can this geotextile be used as a filter? We need to know certain field criteria. Okay, so there are some criteria. So filter criteria. So write it down. Two criteria is to prevent piping and the permeability. Without adequate permeability. Okay. Now we have piping limit. Piping limit is O95 would be less than equal to the D85 of granular soil. And the permeability limit is O90 will be greater than equal to the 15 soil and O90 greater than equal to 0.05 mm. Now for us, O90 is how much? Is 150 150 micron. So 150 micron means 0.15 mm. Right. So 150 microns, right? 150 150 to the power minus 3 and O95 is 230 microns. Now we need to find out the D85 and D15 of the soil. So D85 I will find from here, right? So D85 and D15. 15. So approximately find out from this card, you calculate it. Get D85 as 0.75 mm, D15 is 0.6. So whether can this geotextile be used as a filter or not, you decide now. Is O90 have less than or equal to D85? Yes, it is less than. Is O90 greater than D15? Yes, it is greater. Is O90 greater than 0.05? Yes, it is. So we can use it, right? But this criteria is not getting satisfied, right? O90 is not greater than D15. See, O90 is 0.15, but D15 is, so this criteria is not getting satisfied. So we cannot use it. So filter. Okay. So this is the use of this apparent opening size and all the stuff. Okay. This is enough. Just give me 1 second.
spacers. A specimen, you typically have three normal pressures and three gradients in landfill. Inside of the holder,
shit. The mic was muted. You didn't tell me. Shit. I don't know from where it was muted. But so what I will do, the section where it was muted, I will try to put the audio from somewhere else. Okay, so this is all for today's class, and yeah. Okay, so thank you so much for attending the session, and I hope you had an enjoyable and good class. And we will discuss more in the next session. Okay, in the next session we'll be discussing, as I said, we'll be discussing what the reinforced soil and all those things, and we'll see how all those things are done. Thank you. So with this, we'll end today's session, and we'll meet tomorrow again at the same time. Okay.